Hello everyone. How you doing? Okay. Uh, for those of you that want to play along to answer some of the questions as we go through, I just uploaded the ID. So if you go to that link that I gave you, you can sign in, and it should give a spot on the top there to put in the session ID, and it's going to be that ID number, that 7812 8160. I'll pop that up in the 78128160. And that should enable you to sign in and get to the waiting for next question screen. So I'll give you guys a few minutes to do that, and then we're just going to go through some questions, discuss what we need to, and hopefully it'll be a good review. So kind of start getting ready for spring and get rid of one bug so we can get the flying bug working. So um, if anybody's having any trouble signing in or don't have the link, I'll see if I can find it here. Do, do, do. So put that up in the. All right, I'm just going to run through the first question here so I can make sure everything's working right. Pop that up. Oh, not sure why that happens. I'm sorry. I'm going to have to start it over again. I apologize. Not sure why it does that. Did that last time too. Just give me a second. All right, so I apologize. You have to sign in again using that new session ID, 7812 8536 this time. Uh, So I'll give you guys a few minutes to get signed in there. Always something. Too much technology operating in close proximity. Yeah, fire my producer. So what? Okay, I think hopefully you should be able to hear me now. Sorry, there's a little bit of a lag there, and I forgot to press the button again, the magic button. There you go. All right, so hopefully everybody's had a minute or two with that first question and can pop in and answer. And I'm going to go ahead and uh, click the magic button here. All right, so looks like Fly Guy, whoever that was the first one to get it right. So good job. Most people picked A, temperature inversion with freezing rain at a higher altitude, and that would be the correct answer. So the idea here is that you've got typically where you're gonna get your ice pellets is when there's uh, a warm front in the area. Now, if we look at that from the uh, side view, where it's at the surface, you're going to have warm air going up over top of the colder air below. And so along the line here where the warm air encounters the cold air, you're going to get temperature cooled down to the dew point. Uh, if the temperature is above freezing, it's going to fall as rain. And the air that it's falling into can be cold enough that it freezes it, becomes super cooled on the way down. So that super cooled water is what we got to watch out for as far as the freezing rain goes and the collection on the airplane, clear icing. But eventually, if it gets cold enough, it will turn into little ice pellets and that's what you're going to see on the ground. So if you see ice pellets on the ground, it's an indication that there's a temperature inversion, meaning that it's getting warmer as we go up instead of colder, and there's going to be freezing rain up at some higher altitude. All right, we'll go on to the next question. Oh, you get a figure for this one. I bring these questions out every time, but there's usually questions about them, so I like to keep going over it, get some of these basic ideas. I find if we have the basic ideas, it's one more step to good control and being in command of our airplane. So the question is, 9855 Whiskey in the figure has indicated airspeed of 100 miles an hour. So all three of the airplanes are all doing 100 miles an hour. In which flight condition does 9855 Whiskey weigh the most? Is it in number 3, number 1, or number 2? So number 1 has an angle of attack of 3 degrees and appears to be in a slight climb. Number 2 has an angle of attack of 5 degrees and appears to be in level flight. And number 3 has an angle of attack of 7 degrees and is in a slight descent. So take a moment with that question. Which one of those weighs the most? All right, so to help us answer this question, I don't like to use a whole lot of formulas, but sometimes the formulas kind of will lead you down the path of righteousness. So, paraphrasing it a little bit, lift is equal to airspeed squared times the coefficient of lift, which is directly controlled by our angle of attack. So using that idea, all of them are going to have a constant airspeed of 100, and for this number to go up, then this number needs to go up. So therefore, as the angle of attack increases in this example, it must be producing more lift. And if it's producing more lift, it must need to be doing that because it has more weight. So therefore, the one at the highest angle of attack is going to be the one with the most weight. And that is answer number 3, which corresponds to A here. So letter A. Now, on the next question, we're going to look at the same idea just from a different direction. So I'll leave the formula up there and see if you can come up with the answer for the next one here. So here it says, at 1,950 pounds, 9855 Whiskey has the highest indicated airspeed in which flight condition? Is it 3, 1, or 2? So using that lift formula, you can see on that one the lift is constant on all of these, and the only other variable that we can see is changed is the angle of attack. And so that's what you want to focus on to figure out which one is going to be at the highest indicated airspeed. So go ahead and take a moment with that question and see what you come up with. Okay, so looking at this question here, on all of them, they all weigh 1,950 pounds. The only variable that is changing that we can see is the angle of attack. So as the, for this number here to go up, this needs to go down if we want to keep the lift equal to the weight, which is what our goal is, keep the lift equal to the weight. So therefore, the one with the smallest angle of attack is the one that must be at a higher indicated airspeed. Now, I show the planes purposely, one in a slight climb, one in a descent. Again, the idea here is that technically you could be at the same angle of attack going up, level flight, or going down. The difference in that case would be the amount of power you're producing or thrust. So on this one, I'm thinking that the answer should be number 1, because it's got the lowest angle of attack. So we did a little better on that one, so good job on that. Letter B. All right, we're going to go on to the next one here. So the question is, when would a pilot be required to submit a detailed report of an emergency which caused the pilot to deviate from an air traffic control clearance? When are we required to submit a detailed report of an emergency? Is it A, immediately, B, within 48 hours if requested by ATC, or C, within 7 days? So we had an emergency which caused us to deviate from a clearance. Take a moment with that question. Okay, so some things to know about this. If we have an emergency that causes us to deviate from a rule, the only time we have to submit a report is if air traffic, or if we're requested to do so. And if we are requested to submit a report, then we have 48 hours to do that. So the correct answer here is B. Good job on that. Everybody did really good. So let's go on to the next one. Take a moment with this question. Your transponder is inoperative. What are the requirements for flying in Class Delta airspace? Can we continue the flight as planned? Entry into Class Delta is prohibited, or the pilot must immediately request priority handling to proceed to the destination. So Class Delta airspace, dealing with a transponder. Take a second with that question. Okay, so of the different types of airspace, Class D does not require there be a transponder or ADSB for that matter. So in this case, we would just continue the flight as planned, since a transponder is not required, or ADSB also not required in Class Delta airspace. So we did pretty good with that. Thanks, Brad, for getting the first one right, being the first to get it right. Going on to the next one. Which flight conditions of a large jet airplane create the most severe flight hazard by generating wingtip vortices of the greatest strength? So is it heavy and fast with the gear and flaps down, heavy and slow with the gear and flaps up, heavy and slow with the gear and flaps down? Wonder under what condition are we going to be producing, or is that aircraft going to be producing the greatest vortex strength? Honestly, if it's a large jet airplane, from my perspective, whether it has them up or down, I want to avoid them. But the question here is, when are they going to be producing the greatest vortex? All right, let's see how you guys did. Ooh. So the idea here is with the flaps up, just remember heavy, clean, and slow. That's what you want to remember, heavy, clean, and slow. with the flaps up, it's not getting that extra boost of lift, and therefore the total wing has to be at a higher angle of attack to generate the necessary lift. And so that's why it's got to, uh, that's why it produces more of a wake with the flaps up versus down. When you put the flaps down, you can reduce the total angle of attack of the wing, which is one of the reasons why having the flaps down delays stall a little bit, because when you have the flaps down, you're able to reduce the total angle of attack of the wing, and that reduces your stall speed as well, allowing for a slower approach. All right, next question. See how we do with this. Except when necessary for takeoff or landing, an aircraft may not be operated. Is it A, closer than 700 feet from any person, vessel, vehicle, or structure, closer than 1,000 feet, closer than 500 feet from any person, vessel, vehicle, or structure? Except when necessary for takeoff or landing. Okay, so the main rule is we cannot operate so low as if we lost our power unit. If we lost power, it would cause us to damage persons or property on the ground. So, you know, given that rule, I mean, legally you can fly 2 inches off of the top of Lake Ontario if you wanted to. It doesn't make it the smartest thing you've done all day, but it would be legal. However, we are required to maintain a minimum of 500 feet from any person, vessel, vehicle, or structure. So letter C is the answer there. The 1,000-foot, we have to stay 1,000 feet above the highest obstacle within 2,000 feet of us in a congested area of a city or town. So if you're, flying around, large buildings or something, and there's a building there, if you're going to be within 2,000 feet of it, then you have to be 1,000 feet above it. All right, good job on that. Next question. Using best practice, takeoff should be aborted if, is it A, the airplane fails to reach takeoff speed within the predicted distance, B, the airplane is not off the ground by midfield, or C, you have not attained 70% of your takeoff speed before you have used up 50% of the runway? Using best practice, when should we abort a takeoff? Okay, so some of these are rules of thumb that I've seen floating around. The best answer here is A, the airplane fails to reach takeoff speed within the predicted distance. So the idea here is that you should actually do your job and figure out a takeoff number so that you have something to compare to based on temperature, pressure, wind, slope, the style of takeoff that you're doing. It's best to also, add a 50% margin to any takeoff numbers, for a couple of reasons. One, we, never have the best performance of the plane, pilot, or the exact conditions that we calculate for. And also, uh, you know, where you typically not all the most of the takeoff performance charts are based on a short field or max performance effort, which we're not typically doing in a normal takeoff scenario. So that's going to add distance to that as well. So if my calculated takeoff distance or ground roll was 800 feet and I wasn't off the ground by 1,200 feet, which is, the 1,000-foot stripes begin 1,000 feet down the runway, and they're, I believe, up 175 feet long. So if I'm not off the ground, by the end of those 1,000-foot stripes, if that's what I calculated, then I would cut the power to idle and abort the takeoff. Also, keep in mind that the takeoff performance and the distance up to 50 feet would have you clearing a 50-foot obstacle at 0 feet. So it's just to 50 feet. It doesn't account for any clearance. And again, we're not usually getting the exact performance, so you want to add 50% to that number as well. And if you add 50% to that number, the 50-foot number, and that plus your landing distance is more than the length of the runway, then it's time to start considering doing a max performance takeoff. So even a 3,800-foot long runway on a hot summer day, if the airplane is at near its max gross weight, you're going to use up an awful lot of runway. And if you don't have a lot of good options beyond the end of the runway, in case you have to abort your takeoff, it might be a good time to use a maximum performance takeoff, even though it's a fairly long runway by most standards. All right, going on to the next question. Flight instruments required to be operational for flight include, is it A, the altimeter and heading indicator, B, the magnetic compass and airspeed indicator, or is it C, the airspeed and vertical speed indicator? Which one of those are required flight instruments? Now here we're just talking about VFR flight. So for VFR flight, at a bare minimum, we need to know how fast we're going, how high we are, and what direction we're going. So that's going to be your airspeed, altimeter, and in this case, the magnetic compass is what you're shooting for. Those are required flight instruments and must be operational. And if you find them to be inoperative after you take off, then the airplane is no longer airworthy, and you would need to discontinue your flight and land at the soonest practicable airport. Along the way. So let's see how we do with that. Pretty good job. All right, good job on that. Let's go to the next question. Well, we've got a figure. Dun, dun, dun. Okay, flight to the non-towered airport near Area 1 with an airport elevation of 800 feet. Requires the use of a 4096 code transponder and ADS-B. Requires a transponder and two-way radio communication. Or C, can be accomplished without a radio or transponder if under the Class B airspace. So take a moment with that question there. So the rule with regard to Class B and C airspace with regard to transponders is that if we're going to be flying over or through the airspace, we must have an operational 4096 code transponder. They like to throw that 4096 code thing out there to kind of throw you off, I think, but all transponders have 4096 codes because they have 4 digits that go 0 through 7, and that gives you 4096 code combinations, I guess. But anyway, that's going to be if you're going over or through. So technically, you can go under the airspace, except for the fact that Class B also has a Mode C veil around it, typically 30 miles out from the primary airport. And to operate inside of that, unless you have an airplane that was originally equipped without a power unit, you must have a transponder, and also now you must have ADS-B. So the correct answer there would be A. Technically we can get away without two-way radio communication in that area so long as we stay below 4,000 feet. So you could get into there without radio communication, but you must have a transponder and ADS-B operational to be able to go into that airport. All right, going on to the next question here. So using the same figure, it says operations into the Class Delta airport near Area 2. So up near Area 2. Can only be accomplished if equipped with a transponder. B, as a terminal radar service area providing safety alerts and traffic advisories. Or C, will require aircraft to be ADS-B equipped in 2020. What's the best answer for that question? Operating in Area 2 at the Class Delta Airport in Area 2. Okay, so looking up at Area 2, we see the gray lines there, and the, this guy here indicating that they're talking about a Terminal Radar Service Area, or TRSA. And a TRSA provides safety alerts and traffic advisories. However, that's for VFR flight. Although recommended, it is not required that you talk to that radar service area. You could go into the Class Delta airport without a transponder or without ADS-B. So the answer here would be that it has a terminal radar service area available, but you would still not require a transponder or ADS-B to fly into that airport if you didn't have one. That being said, if you do have that equipment and you're flying in controlled airspace, if it's operational, you are expected to use it anytime you're flying in controlled airspace. And we are flying in controlled airspace most of the time. If we're above 1,200 feet AGL, pretty much anywhere in the United States, if you're above 1,200 feet AGL, above ground level, then you are at minimum in Class E airspace, which is controlled airspace. And so if you have the equipment, you're expected to use it. Let's go on to the next question here. So a minimum of 1,000-foot ceiling and 3 miles visibility must be reported. Is it A, to land at airports within Class C, D, or E airspace? B, to take off from an airport underlying but outside of Class B and C airspace? Or C, to take off at any airport at night? 1,000-foot ceiling and 3 miles visibility. So again, we're talking about the minimum requirements here. So 1,003, commonly referred to as minimum VFR. looking at 91, 157, you have to read past the table that shows the visibility and cloud clearance requirements, but there's a couple paragraphs there that tell you that if you're going to an airport located inside of controlled airspace that goes down to the surface, which can include B, C, D, and E, if the controlled airspace goes all the way down to the surface, to land at any of those airports, you must have reported at that airport a minimum of 1,000-foot ceiling and 3 miles visibility. The other answers there, well, B is just wrong. And C, at night, if we are operating a VFR at night, we must have, if we're in controlled airspace, 3 miles visibility, stay 1,000 feet above, 500 below, 2,000 horizontal distance of clouds. But here we're talking about specifically landing at an airport within controlled airspace. Okay, let's go on to the next question. Good job, Jason, getting the first one on that one. Permission is required prior to operations within A, restricted areas, B, military operations areas, or C, alert areas. Which ones of those types of airspace requires that we must have prior permission before operating within that airspace? Restricted areas, MOAs, or alert areas? Okay, so military operations areas have military operations going on in them, so typically aircraft flying low, slow, fast, and maybe doing aerobatics and or other maneuvers and generally not looking for you. So although we can fly through them without permission, uh, if you know it to be active, it's certainly best to avoid a MOA if you can, but you are legal to fly through it even if it is active. Alert areas are typically issued for areas high concentration of training flights. So I certainly wouldn't want to fly through that area. But restricted areas do require prior permission prior to going in. All right, Mr. Lasky, first one on that one, and everybody got that one right, so good job on that. Let's go on to the next question. Oh, another figure. Okay, so surface winds are likely from the southwest. You are most likely at point 1, 2, or 3 if you have surface winds from the southwest. Most likely at point 1, 2, or 3. One of the games you can play if you understand this concept is, go listen to, the automated weather at a nearby airport and get the winds, and based on the winds, make an estimation as to where the center of the low pressure area is, and then go look at a surface analysis chart and see how you did. The idea here is technically, just by knowing the surface winds, you have an idea of what kind of weather you can expect in the near future. Let's see how we did. All right, not bad. So we've got so around a low pressure area, winds are going counterclockwise. So they're flowing in this direction. They're going to flow clockwise around a high pressure. And, we know that the closer the isobars are, then the stronger the winds are. But because of surface friction, if you think of this as kind of like, your H is your hilltop and your low is your valley and everything kind of flowing downhill into the low area, then what happens then is, think about those big circle the drain things that you can put your coin into. As the velocity of the coin slows down, it goes down towards the center, and that's kind of what happens to the wind. Is as surface friction slows it down, it tends to flex in and point in towards the center of the low. So if we know the winds are from the southwest, it usually deviates by about 30 to 40 degrees. And so if we know that the winds are from the southwest, then that would indicate that we are at point 3. At point 1, surface winds would most likely be from the southeast. And at point 2, surface winds would most likely be out of the northwest. So it's a cool little game you can play with yourself. And like I said, once you have an understanding of that, then just knowing what the surface winds are, you can make a prediction as to where in the weather system you are and what kind of weather you can expect coming up. Let's move on to the next question. So using the same figure, IFR conditions are most likely to be encountered at point 32 or 1. Point 32 or 1. Where are we most likely to see IFR conditions? Okay, so looking at this here, point 1 is ahead of the warm front, and that purple is the occluded front. Remember that what's generating the weather is temperature differential, and where you have cold air and warmer air mixing together, the colder air is going to be at a higher pressure, higher density, and so it's going to push in on the warmer air and start pushing that warm air out of the way. And so as and that's what creates your cold front. And as it's moving that warm air out of the way, that warm air is getting pushed up along cooler air out ahead of it. And so down here at the bottom section here, I kind of show the profile view. So around area 3 is where you're going to see what we have here. You got the warm air or the cold air wedging up underneath the warm air, lifting it up, and that's going to create your showery precipitation and some oftentimes very severe thunderstorms. Now, the greater the temperature differential is between here and here, then the faster that cold front is moving, and the more violent the storms are likely to be. Out ahead of the warm front, you got warm air. We start with ice crystals in the upper atmosphere, creating a little halo effect around the moon. You got those little mare's tails or those little Nike-shaped clouds. And then the clouds start to get lower and lower. You start to get some 8 to 10,000 foot precipitation along the line where the warm air is mixing with the cold air. And this is all happening out ahead of the warm front. And then you get the lower and lower clouds and the all-day steady rain, drizzle. And the greater the temperature differential here is, the slower that's going to move. And so that warm front can really just creep along. And generally speaking, if you take your low and you just block out that L and extend it out like that, this area up here is where you're going to see most of your low clouds and IFR conditions, because all the weather from this warm front is extending out ahead of it and around that path there. So the correct answer here, or the best answer, I believe to be number 1, which is letter C, which is what most of you guessed. So that's good on that. Let's look at let me erase some of this junk here. I think you guys get to use this figure one more time. All right, so while operating near Lake Ontario, lake effect snow is most likely to be encountered at 0.23 or 1. 0.23 or 1. So think about what the wind direction is coming in and the location of Lake Ontario relative to us. And at what point are we likely to experience lake effect snow? All right, so let's see how you guys did. All right, good job. Most of you got letter A, and that's correct, because here is where we got the winds kind of coming out of the north, and so that's going to be bringing moisture in off the lake. Also, it's during the day the ground heats up a little faster, so that air can come in and get lifted or cause lifting. So oftentimes what I see at the airport is I'll show up in the morning and it'll be clear skies, but if the winds are out of the northwest, usually by 8 to 10 o'clock in the morning, we start to see these 1,500 to 2,000 foot clouds show up. By noon, it may even be overcast, and as the day continues to warm up, they'll usually start to lift to about 2,500 to 3,000 feet, and in the afternoon they'll start to clear off. But whenever the winds are out of the northwest, that's typically what we see. Now, anywhere else in the country, when the winds are out of the northwest, I mean, that's when you're going to have your best flying time generally. You're going to have the clear air, great visibility. Might be a little bumpy because you got that cool descending air working around the trees and the terrain, so it might be a little bumpy down low, but that's another unfortunate thing. Oftentimes when the winds are out of the northwest, we also get some of our most challenging landing conditions at our airport with our east-west runway. And unfortunately, a lot of pilots miss out on all the great visibility because of their trepidation with crosswinds and gustier conditions. So something to work on so you don't miss out on all the great views. Once we start flying, the farther away we get from the low, over towards this area, the winds are going to start to die down. And the flying is going to be better. And on this side of the high pressure area, is where most people end up doing a lot of their flying, because we got our light winds. But the drawback there is that now we're starting to get warm air coming from the south. So that's also when we tend to see our hazier conditions when we're on that side of the high pressure. Hazy, hot, and humid, and then we end up kind of on this side of things because everything's kind of a cycle, and we'll get the hazy, hot, and humid in the afternoon, pop-up showers, that kind of stuff. So if you're trying to go somewhere, best to get out of the airport early. Otherwise, you may get stuck waiting till afternoon, and then you're also going to get stuck below, those higher clouds where you're also going to find your bumpier air. So if you're leaving, get your butt up in the morning, get out to the airport, and get out of there. This is a battle I've been fighting since the dawn of flight instruction. And it's a battle I will continue to fight. But keep fighting the good fight. Let's see what we got here. It says a fixed pitch propeller airplane that is operating at 75% power and flying at 4,500 feet MSL will generally A, have a true airspeed that is higher during the summer than winter. B, have a true airspeed that is higher during the winter than summer. Or C, have a fuel burn rate that will be less than at 3,500 feet MSL. So which one of those best answer there? Think about your typical air densities that you're going to encounter and what's going to happen to your density altitude in the summer versus the winter. Hmm. Okay, so we're operating at 75% power, which is going to lead to a constant indicated airspeed or calibrated airspeed. Typically for like a Piper Cherokee 140, we're talking about 100 knots, 115 miles an hour. For our Cherokee 180, you're talking about 105 knots, or 120 miles an hour or so. But in either case, assuming that you're doing the same indicated airspeed because you're generating the same amount of power in both instances, during the summer, the air is less dense, which is just like going up, and so your density altitude is going to go up. And as density altitude goes up, true airspeed also goes up. So for the same power setting and same altitude, during the summer, you're generally going to have a higher true airspeed because the airplane is going to think it's at a higher altitude because of the lower density air. Your RPMs are going to be higher under the same power load, but your fuel burn rate is going to remain pretty much the same on a fixed pitch propeller airplane. If you're generating 75% power, for Cherokee 140, for instance, leaned out, that's going to be about 8.4 gallons per hour at 2,000 feet, as well as 3,000, 5,000, or 7,000. Above density altitude of 8,000 feet, you might even be at full power. Well, I shouldn't say full power. You're going to have the throttle full open, trying to draw in as much air as you can get into the engine, and at that point, the air is only going to be dense enough to generate about 75% power. So for most fixed pitch propeller airplanes that are not turbocharged, your optimal cruising altitude is typically found at a density altitude of about 8,000 feet. And so if you figure on a 80-degree day, the density altitude at the airport is going to be about 2,000 feet. So we got the airport is at 424, but we'll say we're at a density altitude of 2,000 feet, which means from the airplane's perspective, it thinks it's already at 2,000 feet. And so to get to the 8,000 feet of density altitude, we've only got 6 more thousand feet to climb to get to 8,000 feet. So a cruise altitude of about 6,000 feet will get you your optimal performance in the summer, where in the winter you may have to climb up to about 10,000 feet to get your optimal cruise altitude. But it's all based on density altitude. Let's see how we did. Hey, all right. Most people got that one, so good stuff. Okay, let's go on to the next one. An unlocked primer. So an unlocked primer can reduce engine power and cause rough running, especially at low RPMs. Can reduce engine power and cause rough running, especially at high RPMs. Will increase engine exhaust gas temperature. Which one of those is the best answer for having an unlocked primer? So let's see how we did, and I'll talk about it. Pretty good, pretty good. Good job. The engine itself is basically just a giant air pump, and the cylinders, the pistons, when the engine is turning, even with the starter, they're trying to, they're moving and trying to suck air into the engine. And what's preventing that is the throttle valve. So if we got the throttle nearly closed on the engine, then that creates a suction in here. And as we, add power or open the throttle up, that allows more air to enter the cylinder and actually reduces the amount of suction. Now your primer is, oops, is attached to the cylinder head of the engine, typically, not in all airplanes, but most of them. And so at high RPMs, there's not as much suction coming through that engine, so you might not notice a problem with the primer. There may be a slight reduction in power, but it may be imperceptible, especially if you don't fly that airplane that often. But if that throttle is closed or near closed, like if you're in a descent and you've reduced power, that creates a suction, which is now going to be able to, if the primer is open, start pulling more fuel through that primer system and into the cylinder, causing an excessively rich mixture, rough running or poor running. So on the Lycoming engines that we have, on the Cherokees anyway, the primer goes to 3 of the 4 cylinders. So that means that one cylinder is not going to have that problem. So hopefully, that'll just cause a reduction in power. But In either case, anytime you have a reduction in power, you should be going through your troubleshooting steps if it's rough running or whatever, and certainly primer is going to be one thing that you want to check, but you really just want to throw the book at it, right? Throw everything at it and hope one of them sticks. So you're going to be checking your, trying your carb heat, testing your mixture, ensuring the primer's in and locked, swapping your tanks, turning your fuel pump on. You just want to run through everything. But, and running through everything would solve the problem with the primer. I think one of the problems that I hear and see pilots doing is when they have a problem, they try to think it out too much. Just throw everything at it and hope one of them sticks. And if it doesn't, then deal with that, as an emergency. And so you can get have the. Otherwise, you're just wasting altitude that could be better spent. Potentially looking for a place to land or finding some other alternative. But just throw everything at it. All right, next question. So pilots are encouraged to turn on their landing lights when operating below 10,000 feet, day or night, and when operating within 10 miles of any airport, 5 miles of a controlled airport, or within Class B airspace. When are we encouraged to operate with our landing lights on? Okay, so the idea here is that we want to make ourselves as visible as possible. So within 10 miles, that's kind of when you're getting into the airport area. So that's where it's a good time to get that landing light on. So what I like to do is 10 miles out or so, I'll run through and just go through my entire before landing check. So I can get it done and out of the way before I get busy dealing with traffic pattern entries. And because remember, airports are airplane magnets, so the closer you get to the airport, the more vigilant you have to be for traffic. And so you want to make yourself more visible and try to get some of those tasks done early so you don't have to worry about them if you become distracted. So good job on that. Let's go on to the next question. An aircraft without position lights can be flown up to 1 hour after sunset, cannot be flown past sunset, can be flown up to but not beyond civil twilight. So the aircraft does not have position lights. So maybe they weren't installed or maybe they're not operational. In either case, if the position lights aren't working, when do we need to be on the ground? Okay, so position lights. Lights have to be on, anti-collision light and position lights at night. And so the part one, well, in the part one definition of night is 1 hour after, I'm sorry, civil twilight, but that's for the purposes of logging nighttime. The regulation for operating with lights on says that sunset to sunrise we need to have position lights in, anti-collision lights need to be turned on. The 1 hour after sunset has to do with carriage of passengers. All right, next question. So, standard departure from a non-towered airport should be made straight out or by turning 45 degrees to the traffic pattern side. Should be made straight out or by departing on the downwind leg. Should be made by executing a standard rate turn on course upon reaching 400 feet AGL. So standard departure from a non-towered airport. Uh, so good job on that. Now, uh, these are only recommended, but what they've tried to do more and more over the years is standardize things. Uh, when I first started training, you'd have people leaving and departing on many and different legs of the traffic pattern, which could be kind of confusing and difficult for other people operating in the traffic pattern or trying to enter the traffic pattern. So they tried to stress using the recommended standard departure procedures, which is either going straight out or by turning 45 degrees to the traffic pattern side. So typically, you want to go, on one of these departure legs until you're at traffic pattern altitude, ideally 300 feet above pattern altitude before you turn on course. Now, obviously, if terrain or there's noise abatement procedures or other procedures, the straight out or the 45 degree departure may not work, but those are the preferred methods. And I think more and more people are starting to use those, and it just makes it a lot easier for everybody to be able to predict and estimate where the risk is and where the other people are, besides entering on any kind of other pattern. This is something they brought up last year when they're, again, trying to standardize radio communications a little bit, making some recommendations about some of the radio calls that we make. So it says, pilots are reminded that the use of the phrase, any traffic in the area, please advise, should be included when self-announcing position and intention to land, is not a recognized self-announced position and or intention phrase and should not be used under any condition. Or C, must be used anytime you get that nagging, where is everyone feeling? Okay, so the general, consensus is that phrase is redundant and takes up radio time. Anytime somebody announces their position, it's implied that you should respond back with your position. So you don't have to specifically call out any traffic in the area, please advise. If you are the traffic in the area and maybe you've already announced that you're on a downwind leg, but you hear somebody else say that they're 10 miles south inbound, it'd be a good idea to repeat that you're on a downwind leg so that they know what traffic they're going to be looking for as they make their arrival to the airport. All right, next question. Preferred radio call when executing a practice instrument approach at a non-towered airport. This is one of my pet peeves. But is it blah 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 traffic 23 Cherokee 234 10 miles east inbound for a low approach? Cherokee 234 Elvis inbound GPS 28 approach low approach. Or the C 10 miles east inbound straight in approach low approach only. What would be the best phraseology? Think about as a VFR pilot, think about which one of those would tell you the most about that pilot's position and intentions. All right, let's see how we did. All right, so most of you got that. The idea here is, nobody picked B, which is good because, as a VFR pilot, if you're not familiar with instrument approach procedures, you're not going to know and shouldn't be expected to know, where Elvis intersection is or what any of that stuff means. So, but unfortunately, that's the kind of call that you hear the most. It's a call that you would make to air traffic control as an IFR pilot, but when you're going into a non-towered airport, you should be making calls as if you were VFR. So the other VFR pilots in the area can hear and understand where you are. So letter C is the best answer there. So good job on that. Which three ingredients are necessary for a thunderstorm to develop? Three ingredients for a thunderstorm. Okay, so with thunderstorms, you got 3, 3, and 3. You got three stages, uh, three ingredients. So the three ingredients that you need and three types of lifting action. So, think of it kind of like starting a fire. You got to have fuel, air, and spark. So, uh, correct answer is A. Everybody got that? So we got moisture. That's our fuel. We have unstable air, and then we have to have that spark, that lifting action. And that could be afternoon heating causing lifting action. It could be hills or terrain causing lifting action, or it could be a frontal system like a low pressure or a cold front moving in the area that could cause the lifting action. Air traffic controllers will describe the precipitation from thunderstorms as convective or thunderstorm related precipitation. That'd be true or false. Okay, so the thing to think about here is with the air traffic controllers, they don't have, they can see the intensity of the precipitation. So that's what they're going to report is intensity. They don't know lightning or, what the shower looks like. The vertical development. All they know is the intensity, and that's what they're going to report is the intensity level of that storm or precipitation up to extreme. Oh. So nobody picked C. That's good news. All right, next question. If completed within the time period specified by FAR 6156, which of the following events automatically fulfills the requirement for a flight review? Getting a tailwheel endorsement, taking a practical test, or doing an instrument proficiency check. Which one would count as a flight review? All right, so the answer here would be a practical test. Anytime you take another test, whether it be for, that requires a flight check or a flight test from a pilot examiner, so instrument rating, seaplane rating, multi-engine rating, uh, flight instructor rating, certified flight instructor rating. Anytime you get a new rating that requires a practical test, that counts as a flight review. Certainly, if coordinated with the flight instructor providing the training, a tailwheel endorsement could be worked into a flight review, but it does not implicitly count as a flight review. And the same kind of goes with the instrument proficiency check. But anytime you take a practical test, that restarts the clock and counts as a flight review. All right, next question. If your instructor believes your performance during the flight review is not up to par to earn a logbook endorsement, what does that mean that you failed it? The A, no, you cannot fail a flight review. B, yes, but since you met the minimum flight time, you can act as PIC. Or C, yes, and you must restart the flight review from scratch. So, let's see how you did. So you cannot fail a flight review. It's not a test. It is just a review. Uh, the flight instructor providing a flight review has quite a bit of discretion on the content of the flight review. I mean, there's general recommendations. The minimum requirements for a flight review is that we do an hour of ground and a minimum hour of flight. And the only specific requirement as to the content is that the hour of ground must include a review of operating regulations of Part 91. Beyond that, it's up to the instructor. Now, what I typically do is, I'll look through, your law book, and I'll pick tasks, that we typically haven't done in the last 2 years, so that's why you see a lot of, doing air work and other things. But, there's other things to that, trying to get some aeronautical decision making, some single pilot resource management, those kind of things, risk identification, performance calculations. So there's a lot of different things I'd like to touch on and maybe expand on for the flight review. I look to the practical test standards or the airman certification standards, excuse me, as a minimum standard for being able to say, if we've done a maneuver, you should be able to do it to this standard. And, kind of like different arguments you can make as to how it should be conducted, but I kind of think of it like riding a motorcycle. The amount of money you spend on your helmet is equal to how much you think your head is worth. So kind of like the same thing with a flight review. I try to, make it a robust review that's going to, keep your skills developing and again, up to at least that minimum standard. So that being said, and had it happen in the past. You know, if I do a flight review with somebody and I feel like they need a little extra work on a few tasks, and they don't agree, you know, you're free to go to another flight instructor. You don't have to complete the flight review with the instructor that you started with. You would have to start the flight review over and do whatever that instructor asked for, but there's no specific requirement there, and there's nothing stopping you from going to another one after. Uh, During pre-flight, you notice a small ding on the leading edge of the propeller of your aircraft. Are you allowed to file out the ding? Is it yes, because flying the aircraft with a ding in the propeller is unsafe and it is your responsibility as pilot in command to fix the ding? B, no, propeller repairs are not considered preventive maintenance. Or C, yes, propeller repairs such as filing and straightening are preventive in nature. So we got a ding on the leading edge of that propeller. The danger there is with a nick or a ding in the leading edge of the propeller. You know, if it catches your nail as you scrape across it, it could potentially work itself into a crack because it's a high stress area. So to dress out the propeller, we have to file out the stressed material. So the question is, who can do it? Let's see how we did on that. So propeller repairs are not considered preventive maintenance. There are a lot of tasks you could do as preventive maintenance, from changing tires. I mean, you can even change the side windows, service hydraulic fluid. You know, all listed in Appendix A of Part 43. It listed a lot of different things. Now, as an owner of an aircraft and doing a preventive maintenance, just because you can do it doesn't mean that you should do it. You know, everything that you do should be done in accordance with operating manual and the corresponding maintenance standards. At minimum, I recommend that at least the first time you decide to tackle a task on your own, that is done under the supervision of a A&P mechanic. So they can make sure that you're doing it right. But that being said, if you learn to do these tasks properly, you save yourself some money down the road, maybe some time, trying to wait for a plane to get in for an oil change, if that's something that you could do on your own. So add some flexibility to what you're doing. But in this case, filing a propeller is not considered preventive maintenance and has to be accomplished by an airframe and power plant mechanic. What we would have to do is make sure, one, that it's dressed out properly, two, that we haven't removed too much material that would make the propeller unserviceable. So there's standards that go along with it. It needs to be done by mechanics. So next question here. The leading cause of accidents during maneuvering flight is it A, stalls and spins, doing aerial work, or doing aerobatics? Leading cause of accidents during maneuvering flight. So the one of the things to understand about this one is the general definition of maneuvering flight. Uh, Pretty much any time we go fly, we are doing we're doing maneuvering flight. So climbs, descents, turns, we're maneuvering the airplane. And it's been shown, to be a leading causal factor in aircraft fatalities is, maneuvering flight, especially when we're at low altitudes. Operating down low, traffic pattern altitude and below, we don't have a lot of options. And so, and we're closer to the ground, requiring more attention, so we can be distracted. And if we were to get ourselves into a stall spin scenario, we probably wouldn't have the altitude to recover. So stalls and spins are the primary causal factor for maneuvering accidents because they're typically done down low. Aerobatics, unless permitted, they have to be done, there's to allow recovery above 1,500 feet AGL. You're doing them on purpose, and hopefully you've had some training. Certainly, things can happen doing aerobatics, but low altitude maneuvering is a big problem area right now for pilots, and something that we need to be cognizant of every time we go flying. So anything that we can do to reduce our workload, to minimum the amount of maneuvering, below, say 1,500 AGL, you should avoid bank turns greater than 30 degrees of bank. Certainly in the traffic pattern, good airspeed control, good trim control will help with that good airspeed control. Let's go on to the next question here. So it says, let's see, while on the takeoff roll, we notice the engine is running slightly rougher than normal. Yeah, okay. And yeah, we decided to continue the takeoff anyway. As you climb through 500 feet, the engine suddenly quits. So what would be the safest course of action after that? To make a shallow turn towards the airport and land downwind on the runway? To make a steep turn towards the airport and land downwind on the runway? Or to land straight ahead? The safest course of action if we've lost our power at 500 feet above the ground. So, some things to think about with this question is, we're all guilty of it, myself included. We're very quick to rationalize away problems or to discount them as an anomaly, I guess. But certainly, if it doesn't look right, sound right, or feel right, something's probably not right. And, it's certainly best to abort the landing. I haven't aborted too many landings over the years, but I certainly have aborted landings if I didn't feel like I was getting the acceleration I expected, the getting off the ground, the initial climb I expected. I've aborted, several takeoffs over the years just because it didn't look right, feel right, or sound right. On the other hand, especially once we get airborne, we're much less likely to abort the takeoff, even if the plane isn't as performing as well. I guess that's just our nature. But I've taken off an airplane that wasn't climbing as it should. I kept it at VY, and I was only getting maybe about 200 feet a minute when it should have been doing 500 or 600 feet a minute. So I did keep it going straight out. I kept it at VY until I got a safe altitude and turned around and came back. And what came of that is on the Piper Cherokee, there's an orange hose, that comes from the filter to the carburetor, and that orange hose, because of wear, oil getting in it, and just general wear over time, it deteriorated to the point that it was at full throttle. It was fine at the run-up. The run-up was fine. Even the initial power showed, the minimum RPM. But as the flight progressed, I guess that orange hose gradually started to collapse partially, and it wasn't getting in the air it should anymore. So that's why, when we talk about takeoff numbers, the takeoff distance is important too, but also, knowing when you're going to get to that 50 feet in the air. That could become a good measure for what the plane's doing as well, because remember, below a wingspan, which is typically about 30 feet, 30 to 40 feet on most general aviation airplanes, the airplane is being helped out by ground effect. So if you can get to 50 feet in the air in the expected distance down the runway, then you've got a plane that's climbing on its own, and generally as it should. Keep in mind that your vertical speed indicator does lag as well, and so I think that's might have been partially, what I was thinking on the initial climb out is that maybe, it just hadn't caught up to what my actual climb rate was, uh, but certainly I knew I was a little lower off of the end of the runway that I typically would expect to be. But whether, to turn around or not, turning around uses energy that may be better spent finding a safe place to land ahead of us. Keep in mind that we're not thinking, we're looking for the place that's going to hurt the least. We're not looking for, trying to save the airplane. We're just looking for survivability. So around our airport, we don't have a lot of great fields at 500 feet AGL. I find, personally, taking off to the west, we're usually looking to the southwest, and taking off to the east, we're usually looking to the south-southeast, or east-southeast anyway, that area, for the best fields at that altitude. If you have to land with apple trees, pick the one with the smallest ones and try to land with the furrows. There was a plane before I started at the club that lost power on takeoff, and they ended up landing in an apple orchard, and it broke the wings back, but because they landed right with the furrows there, neither the pilot or passenger was hurt in the incident. But we do have a lot of apple trees, so you just want to pick the smallest ones. What I found is that the optimal bank angle, if you are going to turn, is about 30 degrees of bank. Anything less than that, 20 degrees of bank, for instance, your turn radius is going to, you're not going to have as much of a descent, but your turn radius is going to be really wide. Anything more than 30 degrees of bank, you're going to have a tighter turn radius, but your rate of descent is going to go up exponentially. You're going to lose a bunch of altitude that way, and also you stand the risk of increasing your stall speeds, and if you're already at a slow airspeed, that can become a problem in an accelerated stall scenario. If you're on the climb out and you lose power, keep in mind that your VY climb speed is very close to your glide speed, and if you lose power, the engine quits. You need to get that nose down pretty assertively into a nose down attitude to preserve your airspeed. If you wait too long, that speed is going to bleed off very quickly, which is could lead to a stall scenario, and can also require a lot more altitude to regain that airspeed after you do pitch down. So it's kind of counter to what we want to happen, and that's why it can become problematic, especially when we're down low. The last thing we want is that nose to come down. But if you lose the engine, that nose needs to come down, and you need to find the best place to land out ahead of you. Okay, spatial disorientation is only a problem while flying in instrument meteorological conditions. True or false? All right, let's see how you did with that one. So everybody got that one right. It's certainly false. Hazy conditions, anything where we have limited visibility of the horizon line can cause some spatial disorientation, especially if you're, in really hazy conditions. You'd want to avoid flight over lakes, maybe avoid flights at night in really hazy conditions where you don't have as much horizon to look at. We have to put more faith in our flight instruments if we are operating in hazier conditions. But you certainly can get disoriented in other than IMC conditions. What sense do we rely upon for the majority of our sense of balance and movement? Is it the kinesthetic senses, visual, or auditory? So kinesthetic senses, those are the motion feel of turning up, down, left, right. Our body senses, the pressures applied. All right, let's see how you did on that one. All right, well, so you picked B, which is the correct answer, visual. Uh, we rely heavily on our visual, and what can cause the spatial disorientation is when what we see doesn't agree with what we feel. Passengers can get that a lot, because especially if they're looking out the side window, they're in a airplane that's operating, three-dimensionally, which they may not be used to. And again, if what they feel doesn't agree with what they see, it can throw off their senses, and they can cause some nausea and disorientation. But that's why it's so important that if you do feel spatially unaware at all, you get that uneasy feeling, you want to look to your flight instruments to kind of regain some visual control of what's going on. All right, so good job on that one. Let's get up to the next one here. So while in Class B airspace, Class Bravo airspace, and flying VFR, air traffic control tells you to resume on navigation. What does this allow you to do? You're allowed to change heading and altitude at your discretion, change heading at your discretion, but not altitude. So resume on navigation means that just that. You're now responsible for your own navigation. So you're allowed to change your altitude, but not your. I'm sorry, you're you're allowed to change your heading as necessary, but not your altitude. And especially in the Class B airspace, they operate a little uh, more tightly on your altitude control. But you, you should, they'll tell you altitude at your discretion if they're giving you that freedom, or you should, at minimum advise any intention to change altitudes as necessary. But you can change your heading but not your altitude unless advised or requested. All right, so while approaching an airport in Class Delta airspace, ATC responds to your initial call with November A121 Kilo ident. At this point, you are cleared to enter the airspace. Is that be true or false? Or it'd be false because that's my tail number. Oh, but maybe not. We'll assume that it is. All right, let's see how we did with that one. So true, that is correct. Um, to operate in the Class C or D airspace, we have to establish two-way radio communication. The minimum requirement for establishing two-way radio communication is that we hear our call sign read back to us by air traffic control. Now, if they had just said aircraft calling, please stand by, then we cannot continue into their airspace. If this were Class Bravo airspace, then not only do we have to establish two-way radio communication, but we must also we must be cleared into Class Bravo airspace. So we got to hear those words before we go in there. All right. After landing, at what point should you contact ground control? So as soon as the airplane comes to a complete stop, as soon as the airplane is completely past the hold short lines, or when tower tells you. At what point should we contact ground control? So the idea here is that when tower tells you to, that would be the correct answer. Uh, Otherwise, you'd stay on tower frequency. If they didn't give you any immediate instruction, you'd want to get past the hold short marks. You're not clear of the runway environment until you're completely, the entire airplane is past the hold short marks. You would stop and just give the tower a position report telling them that you're clear of the runway, and then they'll handle you from there. Especially at low workload times, they may not have you call ground control. They may handle your taxi with them on the tower frequency. So, but you don't change it over to ground control until you're told to do so. All right, next question. Let's see what we got here. What effect does high density altitude have on your indicated approach speed? So the A, high density altitude increases indicated approach speed. B, has no effect. Is it C, high density altitude decreases indicated approach speed? So what's that going to do to your indicated approach speed being at a high density altitude? Does it increase it, decrease it, or keep it the same? Let's see how we did on that. That's right. So indicated airspeeds are used for performance, aircraft performance, and handling of the airplane, and so they're, with minor exceptions, they're uh, generally going to be fairly constant through the density altitude range. You will find some manuals that, as density altitude increases, some of your indicated airspeeds for takeoff and climb performance might also increase a little bit too. But always just do as indicated in the flight manual for the aircraft that you're operating to get the best performance out of that aircraft for whatever weather conditions or density altitude conditions you're in. But generally speaking, they have no effect, or it's pretty negligible. After reviewing your takeoff performance chart, you find that it will take 1,300 feet to clear a 50-foot obstacle. This means that theoretically you'll clear the 50-foot obstacle by how many feet? You'll clear the 50-foot obstacle by, is it 0 feet, 25 feet, or 10 feet? So based on the performance charts, it's saying that it will take 1,300 feet to clear a 50-foot obstacle. Is that going to get us 0 feet over that 50-foot obstacle, 25 feet, or 10 feet? All right, let's see how you did on that. So good job. That means that you're going to clear it by 0 feet. That's all I was giving you. We talked about that earlier, so good paying attention. Thank you. All right, next question. I just threw these in to be painful. But, here in the club, we have 85 X-ray, which does have a horizontal situation indicator. And you want to have an idea of how to interpret the data coming from that. So when you're looking at a horizontal situation indicator, the idea is that the dial there is kind of giving you a, if you were to lay it down on the ground, it's kind of giving you a top-down view of what's going on. So up here at the top, it's telling you, what direction you're flying. It's saying that relative to the direction that you're flying, the VOR or waypoint is generally over there, and your selected course line, which is east, is generally over there relative to you. So if we, we got B, E, or D. Now, we can solve this really quickly because the HSI does account for aircraft heading. So all you have to do is look and see which one of those airplanes is traveling in that direction, and that might help rule it out. And then relative to you going that direction, so we would be flying a heading of, roughly 220 degrees, flying that direction relative to us. The VOR would be over that way, and our course line would be over that way. And you can see that on that one, the only one that matches that would be letter D. All right, and let's go ahead and go on to the last question of the night. And this one talks about the VOR. Now, the big difference between the VOR and the HSI is that the VOR does not account for aircraft heading. So the key to, interpreting this information is to pretend in your head that you are going that direction, whatever you have dialed in up at the top. So you're traveling to the east. You're past the VOR because you have a from indication. And your course line that you're trying to get to is off to your left. So which one? Now, again, you got when you look at the aircraft symbols, you want to disregard the headings and just look at the relative positions of the airplane. So if we were traveling to the east, going this direction, we're past the VOR, which means that we're somewhere on this side. We have to go to the left to get on course, which would mean that we're somewhere over in this quadrant, which would mean that we are also at position D, just like the last one there. So good job on that. So that's our big springtime review. I hope you guys found it useful. I'll be putting up more content as we go along. I am doing some flight videos. I'll be demonstrating stuff on X-Plane and things like that. I'm just a little more involved than I intended, but hopefully I'll be putting up some content on that. I'm going to have more study sessions as we go along to kind of just keep us thinking about aviation until we can get back up, especially with the training anyway, back up doing some aviating. If you have any questions or other content that you'd like me to talk about, I know I had one request for a 4-flight class, so that will probably be the next thing I work on, is doing a class on using 4-flight for flight planning and things like that. Just let me know. Not that you have to, but if I get 100 subscribers on my channel, I can rename it to a proper name, so I don't have to have all those stupid letters and numbers. So if you haven't yet, just click the subscribe button on the YouTube thing there. Make it easier to pass the link around instead of having all those complex letters and numbers. But that's all I've got for you guys tonight. Thank you guys for joining me, and hope you guys have a good night. We'll see you soon.